In this video, we're going to continue looking at the hypergeometric distribution, and we're going to look at making some tables and tables of the PDF and CDF and a graph of the PDF. Now, in this section, I assume that you have the TI-Nspire with the HGO PDF and CDF functions programmed in from earlier, or that you have a TI-84 or TI-83 with the hypergeometric CDF program that we talked about earlier, programmed in. So let's consider the experiment of drawing 4 cards without replacement randomly from a standard deck of cards. Let X represent the number of spades drawn. What type of distribution does X have? And then once we figure that out, we want to draw a probability tree, write down the PDF formula, make a table for the PDF, and graph it. Well, since we're drawing without replacement, that's going to make this a hypergeometric distribution. And capital N is 52, that's the total number of cards. Capital M is 13 spades. And little n is the sample size, which is 4. So this is a hypergeometric distribution. Here is the table for it. These probabilities at the end are most definitely not reduced. In fact, this 6 times 10 to the 6 is rounded off. Not very well even at that. But the basic tree is set up right with the right fractions. And again, some of these will reduce, but 13 spades out of 52 total cards is 13 52-seconds for P, the probability of success the first time. But if you get a success the first time, the next time the probability of success is 12 over 51. And a failure is 39 over 51. However, if we get a failure, which happens with probability 39 over 52, then the probability of success the next time is 13 over 51. Again, notice all these green probabilities are probability of success, but a success at that stage, which are conditional probabilities later on down the line. And so things change depending on how many you've drawn earlier. This is exactly what's meant by a hypergeometric distribution. And as we've seen in our previous videos, the PDF, or probability that X equals an X value, for the PDF of X is given by this formula here. It's M choose X. That's the way of choosing X successes from a total of M successes. X successes in the sample chosen from the M successes in the population. So M is 13 spades, and we're choosing X, whatever that may be, as the number of spades in our sample of 4 cards. Then capital N minus M, that's in this case 52 minus 13 is 39, is the number of non-spades, the number of failures in the population. Then how many failures in our sample? Well, our total sample size is N, and X of them are successes, so N minus X are failures. So that's 4 minus X here. So that combination is the number of ways of choosing the 4 failures. This combination is the number of ways of choosing the X successes. This is 4 minus X failures, I should have said. The denominator is the total ways of choosing the 4 cards, which is capital N choose little n, choosing a sample of size n from little n from a population of size capital N. So in other words, 52 choose 4 in this case. So this is the PDF formula. Now we can use that formula to generate a table and a graph, and here it is. Now let's take a look at how we can actually use some features of the calculator here to help us with this. So I'm going to go to Stat and Edit, and I'm going to clear these things out, clear lists, say maybe list 1, 2, and 3, just clear them out like this. So here we go, and clear. And we can start by putting the X values in here. There's not very many, so I'm just going to type them in like this, 0, 1, 2, 3, 4. And we can put them in like that. Now, for list 2, you can actually put your cursor on the L2 and put a formula in. And we're basically going to put in this formula. So open parentheses for the numerator, then I'm going to put each combination in parentheses. So open, 13, choose, math, probability, number 3, choose X. Now where is X? X is going to come from L1, so I'm going to do second 1 to get L1. Close parentheses, times, parentheses, 39, choose, math, go here, 3, choose, well, 4 minus X. So I'm going to put that in parentheses. 4 minus Now x is also from L1 again, so L1. Close parentheses on the 4 minus L1. Close parentheses on the choose. 4 close parentheses on the numerator. Divide by, let's put parentheses around the denominator, 52 choose 4, and hopefully when I hit enter, there are all the probabilities right there. Okay. Now I have a couple of ways of getting the, well, actually really one good way of getting the CDF. And that is, I mean, I could add them up by hand, but I can also go to L3, put my cursor on L3, and anytime we have a CDF here, these have to be in a PDF in L2 with the X's are in L1 in increasing order of the X values. These are the corresponding probabilities or PDF values. To do the CDF, we can do a cumulative sum of L2, and you can do that by second list. I think it's under operations. Yes, number 6. Cumulative sum of list 2, and hit enter, and that gives you the right thing. The first one's the same, and then the next one is these two add together, and the next one is those 3 add together, and so forth. And of course, you can see that it does end up at 1, which is definitely a good sign because it's supposed to do that. And here's a big version of the same screen right here. It's even easier in a way to do this on the Nspire. And the Nspire, we need to go to Home and add a spreadsheet page. I can put my data here, which I'm just going to call it RV for the random variable. I really don't want to just call it X, but and well, it's not very many, so I'll just type them in: 0, 1, 2, 3, and 4. Now I can go up here, and this is going to be the PDF. So I'm just going to label it PDF. And just like if you're typing this in Excel, you start a formula with an equals. So you say equals. And I already have a Hypergeometric PDF built in. Or not built in, but programmed in, because we programmed it in. So HGO, of course you have to have this in first, PDF, and it recognized it. You can tell by the way it did the typing there, of, well, NP, and so the first one is capital N, that's 52 cards to choose from totally, size of the population. How many successes? Well, there are 13. And we're going to choose a sample of N, which is 4 cards. And then for this, I want to use cell A1. And enter, and there's the probability. By the way, notice it came out as a fraction, so that's the exact value. Okay, I'm going to Control C to copy, and over here Control V for paste. This is messed up here because it's working. We're in B1. I want it to be A1. Okay, but I want to go up here and I want to do Control Enter so that it will. No, I want it to approximate. So actually, to force it to approximate, I want to have to put approx in front. PP ROX will do it. And do that. And there it is as a decimal. Now I can actually take those two cells, highlight them, Control C for copy. Oh, before, yeah, that's good. Control C for copy, and then highlight these cells here, and do Control V for paste. And I believe that will come out with the correct values. Yes, those are correct. Actually, these are exact values in fraction form, and decimal values here. So this is also the PDF approximately. For the CDF, I have a couple of options. One is I can say I can do a cumulative sum of that one, just like I did on the other calculator. But I also have a CDF function built that I've programmed in, so let's use it. Equals, let's make sure it approximates this time. APP ROX. I'm sure you can get that from a menu somewhere too, but let's do it. I could just type it in. Approximate HGO CDF this time of, okay, again, N is 52, capital N is 52, M is 13, little n is 4, and for this one I still want to refer back to cell A1. Oh, I'm sorry, I forgot. This has to go from, we want the CDF, it needs to have an extra argument. It's from low to high, right? Low is 0 and high is A1. There we go. And if I copy that, Control C, and then highlight here, Control V, now we have the CDF right there. So I could even label that CDF if I wanted to. Okay? And that gives us a way, so we made use of our functions that we had programmed in. So either way, there's a table, and you can get the calculator to sort of do them all at once if you sort of enter in the program the right way. Okay, so here's the table of the PDF and CDF with a certain number of digits there. We probably wouldn't necessarily need all those digits normally. And then here is the graph of the PDF right here. Little short bar here at 4. Okay, so the mode is 1, highest bar. So remember our defining parameters. The total number of objects is N equals 52 cards. The number of successes is M equals 13 spades. Number of objects selected is 4 cards for our hand that we're selecting. X is the number of successes in a sample. It's variable, but it's either 0, 1, 2, 3, or 4. And the probability of success on the first item is M over N. That's 13 over 52, which is 1/4 or 0.25. The probability of failure is 1 minus that, so it's 0.75. The mean turns out to be N times P, so that's just 4 times 1/4, which is 1. So 1 is both the mode and the mean. It's also the median, and you can see why is it the median. The median is the first X value in the CDF is at or above 0.5. So the first time this gets at or above 0.5 is at 1, so 1 is the median as well. The variance is this thing without the square root. It's N minus big N minus little n over big N minus 1 times NPQ, and I just worked that out with a calculator here, and I got this number, square root that to get the standard deviation there. So you see how you can work some of this out. Okay, there I just added a couple things. I switched these numbers to round off to 4 decimal places, because we really didn't need all that many digits to see the point of what's going on there. Same way down here. I noticed that the number of successes in the sample is X, but that's variable, but it has to be one of these 5 numbers, 0, 1, 2, 3, or 4. And then I've added the data labels from the PDF to the graph here, and we see that they match what's in the table here. So just made a couple little slight cleanups on that slide. We'll work some more with hypergeometric distributions in the next video.